Here we have a problem on integration. That is, we have to integrate the function cosine x times square root of 9 positive 25 times sine square x dx. Okay, here when I look at the stuff in the given function, particularly the stuff we have inside the square root, that is 9 positive 25 times sine square x. So I can remember a formula for integration of a radical function, that is square root function. So that is integral square root of x square positive a square dx. Okay, so when we have a square root function in this form, its integration equals to x over 2 times the square root of x square positive a square positive a square over 2 times natural logarithm of x positive square root of x square positive a square positive c. So if I get the function in our integration is in this form square root of x square positive a square, I can use a formula to get integration of the given function. Okay, first let me rearrange the terms in the given integration over here. Okay, let me do it. First, let me write the given integration as it is. It is integral cosine x times square root of 9 positive 25 times sine square x dx. Okay, integral. Okay, square root of, let me write this 9 as 3 square positive, this 25 as 5 square, and this sine square x can be written as sine x the whole square. And I am writing this cosine x along with dx because this one, all of them are in multiplication. So we can write this cosine x along with dx using multiplication. Then I'm getting cosine x times dx. Okay, in my next step, integral square root of 3 square can be written as it is and positive. So here two terms are in multiplication and both the terms are having the same exponent too. So what we can do is we can write the exponent in common, that is 5 times sine x the whole square times cosine x dx. Okay, in my next step, integral, so square root of, so first let me write the variable part. So because here the variable part we have at first inside the square root. So we can write 5 times sine x the whole square positive 3 square times cosine x dx. Okay, let's compare the square root over here and the square root over here. So instead of a square, we have 3 square. But here, if we have a variable and it is square. But here, instead of variable, we have 5 times sine x whole square. So instead of 5 times sine x, instead of this trigonometric stuff, I just need a single variable over here and it has to be square. So what should I do? So that I can get this one exactly in this form, I can use the formula we have over here. So what I have to do is for that, I have to do a substitution, method of substitution to get a single variable over here. So for that, let me assign a new variable, something like u. Let u equals to 5 times sine x. Okay, now I'm going to change the complete integration to the new variable u. So when I change the complete integration to the new variable u, I have to do integration with respect to u. That means at the place of dx, I must have du. Here I have u. If I want to get du, what should I do? So I have to find derivative of this u. So if I get the derivative of this u, I'll be getting du. And also we have the original integration, the variable x. So now in this equation, u equals to 5 times sin x, I have to find derivative on both sides with respect to x. Okay, if I find derivative of this u with respect to x, I'm getting du over dx equals to, on the right side, so this sin x contains a variable and we have to consider the whole stuff sin x as variable. This variable is multiplied by the constant phi. Whenever I find derivative of a product where a constant is multiplied by the variable, I have to keep the constant phi as it is and I have to get the derivative of this sin x. So the derivative of sin x is cosine x. Okay, now, so I got the derivative of this equation with respect to x. I got d over dx equals to 5 times cosine x. Okay, now let me multiply both sides by dx. Okay, so when I multiply both sides by dx, is dx will cancel out. I am getting du equals to 5 times cosine x times dx. Okay, here when I look at the integration over here, I just have cosine x dx, but here we have 5 times cosine x dx. So now I have to get rid of this phi so that I'll be getting some stuff which is equivalent to cosine x dx. It can be plugged in for this cosine x dx into the integration over here. So for that, I multiply both sides by 1 over 5. Let me multiply the left side du by 1 over 5. On the right side also I have to multiply by 1 over 5. So 1 over 5 times cosine x dx. So this phi will cancel out. The resulting stuff is 1 over 5 times du equals to cosine x times dx. Okay, now so I have completed the substitution work. Now in this integration, what I need to do is I have to replace this 5 times sin x by u, and this cosine x dx has to be replaced by 1 over 5 times du. Okay, let me continue this on the next page. This is a step we had on the previous page. Okay, as we have discussed already, integral square root of this 5 times sin x has to be replaced by u, because already we have assigned this new variable u for this 5 times sin x. So we can plug in u for this 5 times sin x. Since we have square for 5 times sin x, so we can square this u positive 3 square. And also we have discussed the stuff which is equivalent to this cosine x dx on the previous page. That is 1 over 5 times du. So we can plug in 1 over 5 times du for this cosine x dx. Okay, let me write it over here, 1 over 5 times du. Okay, now this is a function. In this function, the constant 1 over 5 is multiplied by the complete stuff over here. When we do integration in the function, complete stuff is multiplied by some constant, we can move the constant out of the integral. So because the integral will do nothing with the constant, which is multiplied by the complete stuff in the function. So we can move this constant 1 over 5 out of the integral. Then we get square root of u square positive 3 square times du. Okay, now this integration is completely in the form of integral square root of x square positive a square dx. Already we know the formula for this one that I've written over here. So now we have to take the same formula to get integration that we have on the other page. So we just have to write u instead of x at everywhere over here, because in our integration, instead of x square we have u square, and also at the place of a square we have 3 square. So on the right side in this formula, so at everywhere I have to replace x by u and a by 3. Okay, let me continue this on the next page. Okay, now let's get integration of this one. That is 1 over 5 times x over 2. That means instead of x we have, so we have to write u over 2 square root of u square positive 3 square positive a square over 2. But instead of a square we have 3 square, so we can write 3 square 2 times the natural logarithm of x positive. That means instead of x we have u positive, and square root of u square positive 3 square positive integral constant c. Okay, so I've written the formula we have over here as it is. So at the place of x, I just I've taken u. At the place of a, I've taken 3. So because instead of x square positive a square, we have u square positive 3 square over here. Okay, now so now actually u is the variable taken by us to make the integration process easier. It has to be replaced by the original stuff. What is the original stuff? So for u, already we know that 5 times sin x. So let me plug in 5 times sin x for u. So 5 times sin x over 2 square root of, for this u square also I have to plug in 5 times sin x the whole square positive. We can evaluate this 3 square, its value is 9 positive. So here also the value of 3 square is 9 over 2 times natural logarithm of, for this u also we can plug in 5 times sin x positive square root of 5 times sin x the whole square positive. So the value of this 3 square is 9. Okay, positive c. Let's do simplification. So 1 over 5 times sin x over 2 square root of. Okay, so here we have 5 times sin x the whole square. So 5 times sin x the whole square, and inside the parenthesis 5 and sin x are multiplied. Whenever two quantities are multiplied, we have the common exponent. The exponent can be taken separately for this 5 and separately for this sin x. So when I do so, I'll be getting 5 square times sin x the whole square. So further, so 5 square can be written as 25, and the sin x whole square can be written as sin square x. So 5 times sin x the whole square equals to 25 times sin square x. So we can plug in this 25 times sin square x for this 5 times sin x the whole square. Okay, let me do it just a moment. So 25 times sin square x positive 9 positive 9 over 2 times ln of 5 times sin x positive square root of the same thing here, 5 times sin x the whole square. Already we got the stuff, that is 25 times sin square x positive 9 positive c. Okay, now let's distribute this 1 over 5 to each term inside the parenthesis, inside the square bracket over here. So when I distribute this one to this, I'm getting 1 over 5 times 5 sin x over 2 times square root of 25 times sin square x positive 9 positive. So let's distribute this one to this, and I'm getting 1 over 5 times 9 over 2 times ln of 5 times sin x positive square root of 25 times sine square x, positive 9, positive c. Okay, here this 5 will cancel out and we get 1 over 2 times sine x here times square root of 25 times sine square x, positive 9, positive. So 1 times 9 is 9, 5 times 2 is 10. I'm getting 9 over 10 times natural logarithm of 5 times sine x, positive square root of 25 times sine square x, positive 9, positive c. So this is the integration of the given function with respect to x.